Welcome back to Missouri Caves and Speleology. We're going to continue with our lessons on karst hydrology, and the focus of this lesson will be non-point source pollution. And once again, I'm Toby Dogweiler. So the last time you heard from me, I left you with the question, should you drink that spring water? And we talked about that spring water being the output of a karst system is very susceptible to pollutants. Karst in general is a very sensitive hydrologic system that can easily become polluted and doesn't have much ability to break those pollutants down or process them in the ways that other systems sometimes do have. We'll start with a little story about a spring that I've been involved with some work on over the last 15 years or so in southeastern Minnesota. This is called Fountain Big Spring. It's near the town of Fountain, Minnesota. There's actually two springs. They're on either side of the road, but they're hydrologically connected. The water just sort of comes up into both from the same conduit that runs underneath both springs. And one day the Minnesota Pollution Control Agency, which is the regulatory agency at the state level in Minnesota that's charged with regulating and protecting water quality, was conducting a field trip for various people from other agencies and universities. And during the field trip, they stopped at this spring to show it as an example of a spring. They were trying to teach people about karst. And they pull up and they look, and this spring, which in these pictures is running perfectly clear, was running chalky white. Well, this was a bad day for the quarry that's just upstream from this. In the aerial photo that I'm showing you here, there's a white area towards the bottom center. That's a large quarry, and this quarry drains directly to that spring, and part of their permit for operation indicates that they have to protect the water quality in that spring by limiting the ability of sediment and other things from the quarry to get into the groundwater and be discharged at that spring. So they ended up with a fine after that day. But as I said, water in these karst systems can move really fast. If it wouldn't have been a day that those people from the Pollution Control Agency happened to be there, maybe even if it were a few hours earlier or a few hours later, the spring would have looked just like it did in the picture. These karst systems are very flashy. If it rains hard right now, in 15 minutes, 20 minutes, an hour, or a day, the spring will start to run with a lot of water. And then just as fast, just as quickly, the water level will come back down. Now that lag time between when it rains hard and how long it takes for the flow to show up at the spring is a factor of how big the system is, how large an area drains, and so forth. But because this quarry, which is right next to those red stars, the springs are those three red stars on the left, because the quarry is so close, it's just a quarter mile or so. When it rains, if anything bad happens in that quarry, it's going to show up in the spring almost instantaneously in just a few minutes. So that talks a little bit about a point source of pollution in that case, where we know that that pollution was being caused by some activity in that quarry and was directly impacting that spring. So a previous lesson talked about point source pollution. This lesson we're going to focus on non-point source pollution. The EPA states that non-point source pollution generally results from land runoff precipitation, atmospheric deposition, drainage, seepage, or hydrologic modification. Non-point source pollution, and this is the really important part, unlike pollution from industrial and sewage treatment plants, comes from many diffuse sources. So whereas with the quarry we could point our finger to that is the point where the pollution was being sourced. With non-point source pollution, we may know that this general area of the watershed or this general area of the landscape is the source of the pollution, or this particular land use, but we can't point to a specific spot on the landscape because the pollution is coming from a broad area from a lot of activities. So let's talk about that for a second. Non-point sources of pollution can come from agriculture, from urban areas, from just about any land use that we typically encounter in human societies. The picture in the center on this slide shows some cows that are grazing right next to a stream. Some of the cows are actually in the stream. This is in a karst area. So those cows are a non-point source of pollution. Sure, any one cow that happens to, do its business in that spring or that stream, that stream might be a point source of pollution, but when you think about how many cattle are spread across this agricultural landscape, it's all those cattle combined that make a significant pollution source. And then the picture on the right there is, you can see by the rainbow sheen on the water, some motor oil that's gotten into the water and is seeping into the soil. And that happens in, think about how many different places in a city or an urban area that might happen every day as water runs across concrete surfaces and asphalt and picks up hydrocarbons and then moves into the soil or into the stream. So these are all non-point sources of pollution. I'm also bringing back a photo from an earlier lesson that shows the epikarst, that upper layer of karst of dissolved bedrock in the system. And here you can see the corn stubble at the top of the picture, a very thin soil, which is typical in karst areas, and then the dissolved bedrock where that limestone is being attacked by dissolution at the soil bedrock interface. So think about it, as that farmer cultivates the corn across that whole field, we're just seeing the very edge of that field, herbicides, pesticides, fertilizers are all being applied. Some of those are being taken up by the plant or broken down above the soil, but some of those are going to move into the subsoil and they're going to move into the karst and they're going to become a non-point source of pollution in the karst area. The picture in the lower right shows a tractor that was driving up a grass waterway on a field that farmer has farmed his whole life, and his father and I think his grandfather before them. This is a farm that's been in the family for many, many years. And just one day that tractor was driving through that grass waterway right as a sinkhole opened up. The weight of the tractor probably caused the sinkhole to open up. But what's behind the tractor? He was pulling a sprayer. So that just really illustrates these connections in this karst landscape, that what's happening on that field in terms of the agricultural practices can result in direct runoff through the soil or through sinkholes into the karst system. Another common feature of many agricultural landscapes is feedlots. And feedlots, sometimes these are really large operations like this one, and you can see all the manure storage units there behind the barns where the cattle are kept. Now, in this case, this is a very high-tech system that's meant to keep that manure contained so that it doesn't leak into the karst system that underlies this area. But the use for that manure is to fertilize the fields. So they pump the manure out of those basins, spread it across the fields that you can see in the picture, and that's the fertilizer. If they over-fertilize, the excess nutrients end up moving into the soil, moving into the groundwater, moving into the karst system and become a source of pollution. And in that sense, because there's a lot of excess nutrients applied throughout the agricultural landscapes of Missouri, Illinois, the whole upper Midwest, essentially that whole upper Midwest is a non-point source of pollution for nutrient runoff into the Mississippi River and the Gulf of Mexico. The next slide just further illustrates this. I've shown a watershed here, and the different colors, the maroon color in this watershed, are areas that have a high probability of sinkhole occurrence. So these are areas that are very susceptible to the development of sinkholes. So that's also a measure of areas where we have the best connection between the karst system and the overlying surface. The blue stars in this picture are sinkholes. The other areas have less likelihood for sinkholes, but we can think about some parts of this watershed then are going to be more sensitive to different land uses. It may be better to site a feedlot on one of the gray areas here where sinkhole development and the connection between the karst and the surface is not as good, versus in the maroon areas where that connection is really direct. That may be a less good area for certain types of land uses. Now this is that same quarry and spring that we started out this lesson with, the Fountain Big Spring in southeastern Minnesota. But what I want to show here is we have sinkholes all across this landscape. All of those blue stars in this diagram, in this map, are sinkholes. Those are all places where pollutants can get directly into the karst system. But all the soil, all the land area in between those sinkholes is also areas that water can move diffusely through the soil into the bedrock eventually. So we have a large agricultural area here, but you do also in the center of the photo see a small town there. That town is maybe a few hundred or 1,000 people in it. Each of those homes has a septic tank, and each of those septic tanks, if they're not kept up, becomes another non-point source of pollution, because if those septic tanks don't function properly, they don't fully process the septic materials, and they can pollute the groundwater and the karst systems. Now, why do we care about this? Who cares if our caves get polluted? Most people don't live in caves. Most people don't even spend much time in caves. Well, first of all, there are ecosystems in caves, and we want to protect those ecosystems. We've talked about in other lessons karst biology, cave biology, and some of the very sensitive critters that live there that are unique and I think very much worth protecting. But also a lot of trout streams. I know a lot of people love to fish. Trout fishing and fly fishing is a very popular pastime throughout much of the U.S. And many trout streams are fed by springs that drain karst systems. So what you see here in the center is a large spring in Missouri. That spring feeds a stream. That stream supports a healthy trout population, and you have trout fishermen like the gentleman in the lower left there catching, that's probably a 20-inch trout. That's a real prize. And trout are very sensitive to water quality issues. So if we have poor water quality in these streams because of all the pollutants moving through the karst system, we're going to see a decrease in the productivity of those trout fisheries. But also humans drink this water. Humans drink water in many karst areas. 20% of the world's landscape is underlain by karst, and so the people who live in that 20% of the earth are dependent on those water resources. Finally, I don't want to just pick on agriculture. Agriculture is a big land use throughout much of the U.S., in the middle part of the U.S. especially, and impacts a lot of karst through the U.S. But also this is an urban area, I believe, in near Tampa, Florida. And what you see in the right side of the picture is a label for Blue Sink, which is a sinkhole. This whole area is karstic. And then there's a spring just offshore, off the coastline there, called that's labeled Crystal Beach. That's the spring. It's the downstream end of a cave system. So this sinkhole and not just the one that is labeled, but this whole urban area here and all the things that go on in urban areas. We talked about hydrocarbons, from cars that run off of concrete, but also think about industrial, other sources of pollution that could happen in a city. Dry cleaners, gas stations, these are classic sources of pollution in urban areas that could eventually make its way into that cave system and come out there directly into the ocean through the spring that comes up in the floor of the seabed there, just off the coast, that could pollute that whole coastline potentially. So we have good reason to want to understand and protect these karst resources. So what can we do? I gave you a couple of examples. A lot of people have septic systems, especially when you don't live in an urban area. You probably depend on a septic system. Take care of it. Getting that septic system properly pumped out and inspected every couple of years, it both protects your investment and the groundwater. If you have a septic system, you're also likely to have a well. You don't want to pollute your own groundwater with your own septic system for obvious reasons. If you're a farmer, or if you're a gardener, or if you have a yard in a city, minimize the amount of fertilizer, pesticide, and herbicides that you use on your lawns or your fields. You can see in the pictures here, the lower picture is a sinkhole in Jamaica that's full of trash. The other one is a sinkhole in Minnesota that's full of trash. Many sinkholes across the karst lands of the U.S. and the world have been filled with trash. It's convenient. You throw your trash in there and it just sort of disappears. Well, what you need to do is understand the connections between the surface and the groundwater. What goes into those sinkholes goes into our water, our groundwater resources through that karst system, pollute our water table, pollute the water resources that we depend on. So the best thing you can do to protect karst is to understand these connections and think about what's the most appropriate ways to manage these landscapes if you live in them. With that, we'll end this section of our lesson today, and I thank you for joining us for Missouri's Caves and Speleology. Thank you.